Hi and welcome to our video presentations. Today, we will be exploring one of the most important techniques in analytical chemistry, volumetric analysis, and how it plays a crucial role in the food industry. Volumetric analysis, also known as titration, is a method used to determine the concentration of an unknown solution by reacting it with a solution of known concentration. This technique is widely used because it is simple, accurate, and cost-effective. In the food industry, maintaining product quality and safety is essential. That's why volumetric analysis is frequently used to test for things like acid content in beverage, salt levels in processed food, or even the amount of preservative in product. Through this technique, food manufacturers can ensure consistency, meet regulatory standards, and protect consumer health. In this video, we will walk you through how this method is applied in the food industry, the theory behind it, and some real examples to give you a clearer picture.
Hello everyone, today I will be explaining the theory behind volumetric analysis and how it's applied in the food industry. Volumetric analysis is a quantitative method used to determine the amount of a substance in a sample by adding a standard solution of known concentration until the reaction is complete. Then, measuring the volume used. A standard solution is a solution with a known concentration. This technique is important in the food industry to ensure product quality, safety, and accurate labeling. There are four main types of titration: acid-base, redox, complementarity, and precipitation. Acid-base titration is commonly used to measure the acidity of vinegar, fruit juice, and yogurt. Redox titration helps determine vitamin C content in juice and supplements. Complementary titration measures calcium and magnesium in milk and dairy products. And 4. Precipitation titration is used to detect chloride level in salty and processed food. For astranoid, an indicator is often used to show the endpoint of a titration by changing color when the reaction is complete. These titration methods help manufacturers monitor nutritional values and maintain consistent standard in food products.
Hi everyone, I will talk about methodology. Firstly is a sample preparation. Objective for this is ensure the sample is suitable for titration. Detail: for liquid such as vinegar or juice, dilute with distilled water to reach a measurable concentration. For solid, powder or fluid, dissolve or extract analyte with appropriate solvent. Filter if need to remove solid particles that may interfere with titration. For example, dilute 5 ml of vinegar to 50 ml of using distilled water. Secondly, is preparation and standardization of titrant. Objective for this is to ensure the titer solution of known concentration is accurate. Detail: prepare titrant like NaOH for acid base and iodine for redox. Standardized using a primary standard. NaOH is standardized using an oxalic acid for acetic acid titration. Iodine is standardized using a sodium thiosulfate for abscisic acid analysis. Note: standardization is crucial for accurate results, especially if titrant absorbs CO2 or degrade over time. Titration procedure: pipette a fixed volume of sample into conical flask. Add indicators such as phenolphthalein or starch. Fibrate with titrant and record in shear volume. Titrate slowly, add titrant while swirling until endpoint is reached. Observe indicator color, change that signal the endpoint. For the endpoint detection, use visual indicators: phenolphthalein colorless to pink for acid-base titration, and starch colorless to blue-black for iodine titration. Stop titration immediately when the indicator changes color permanently for at least 30 seconds. Calculation of result. First, you have to recall final bureau reading and calculate titrant volume used. Use balanced chemical equation to relate moles of titrant to moles of analyte. Formula: if M1V1 equals to M2V2, which is acid minus base titration. Convert moles to concentration in moles per liter or percentage weight over volume depending on the application. Example: percentage acetic acid equals to volume of NaOH times molarity times molar mass divided by volume of sample times 10.
So right now, I'm going to explain to you the example result of the volumetric analysis in food industry. And the first one is the determination of acidity in vinegar using the volumetric analysis. So we identified that after performing the titration, we found that the volume of sodium hydroxide now is required to neutralize 25 ml of vinegar was 22.5 ml. Using the titration formula and the molarity calculation, we determined that the concentration of the acetic acid in the vinegar is to be 0.90 mol per liter. This value is close to the expected acidity level that were found in the commercial vinegar, showing that the product meets the quality standards. The next example is the vitamin C content in the orange juice. By using the iodine solution in a redox titration, we determined that 20 ml of orange juice contained approximately 35 mg of vitamin C, or what we call ascorbic acid. These amounts aligns with the nutritional information provided on the packaging, confirming the product authenticity. So I'm going to explain the third and the fourth example for this volumetric analysis in the food industry. Okay. The third is the salt content in soup. After titrating the soup sample with a silver nitrate, we calculated that the chloride ion concentration is to be 0.12 mol per liter, which corresponds to the 7.0 grams of salt per liter. This helped to monitor the sodium level and to meet the health and labeling regulations. And the last example is the lactic acid in yogurt. The titration of 10 milliliter of yogurt with 0.1 mol now revealed a lactic acid concentration of 0.85% weight per volume. This confirmed the fermentation process was successful and the product is within acceptable acidity limit for quality control. That's all.
In conclusion, volumetric analysis is more than just a lab technique. It's a powerful tool that supports the quality, safety, and truthfulness of the food we consume every day. It helps food manufacturers meet strict safety standards, ensure products are consistent, and protects public health. From the moment ingredients are tested in a lab to the final product placed on store shelves, volumetric analysis shows how chemistry plays a vital role. It helps us trust what we eat, and that trust is something the food industry cannot afford to lose. So, whether you are a scientist, consumer, or someone simply buying snack at grocery store, this technique is working behind the scenes to keep our food safe and reliable.